Howdy, howdy, this is Mr. Potter. What we've done so far is we've talked a lot about the memory allocation in C++, and that's one of the main ways that C++ is different from the other C-type languages, Java and C# that we've dealt with. So what I plan on doing in this next unit is we're actually going to develop a class in C++. The original C language didn't have classes. They had something called structs, which we'll talk about in a later lesson. And C++ added on classes, but they're not as elegant as they are in Java. The way that we have to do them in C++ is a little kludgy, and so I want to go through the steps here. So I'm going to open up a file, and we're going to call this fraction.h. Now you may notice that this is not a CPP file, this is a .h file, and that stands for a header file. So fraction.h, this is actually going to contain all of the prototypes in one definition. So what we'll often see in C++ programs is that we'll have all of our prototypes in one file, and then the actual code in a separate file. That'll be our CPP file, where all of our code is. But the header file will take care of all the definitions for us. Now, in order to do this, I actually need to define a class, so we're going to do class fraction. Now, I'm not actually going to have my main in here. I'm actually going to have a third file, which we're going to create a little bit later in the video for our main. But I'm doing a class definition here. So I say class fraction. And I don't have to put public or private in it. In fact, the name of the file and the name of the class don't even have to match. Notice that I've capitalized fraction here. And in the Linux system that we're running, capitalization is distinct from the lowercase version of fraction. For us, we're going to be using the capitalized version of fraction for our class. Now, when I'm creating a class, we do actually need to keep track of what is private and what is public. The things that we would need to be public are things like our constructor, our accessors, and our modifiers, or our mutators. And the things that we would have that are private would be our instance variables, as well as any helper functions. So these are the two things that we're going to have inside of our class file. Now, this is actually a statement, and so I need to make sure that I terminate it with a semicolon. So we're creating a fraction object. Now, a fraction really has two parts to it that we have to keep track of. We have to have a numerator, and we have to have a denominator. And notice that I am, including them in the private part of our class because these are instance variables. They shouldn't have, the clients and the users shouldn't have direct access to this. What should happen is that we should have a constructor which would create a fraction with two parameters, an int num and an int den. And then we would assign those values of those parameters to numer and denom, our two instance variables. And we're probably going to need an accessor for each of these. So we're going to have to return ints. So I'm going to call this get numer and int get denom. Now what you need to remember is that these are prototypes, and so I'm just putting the return type, the function name, and the parameter list. Of course, for accessors, I shouldn't need parameters. I'm going to create one more accessor called getValue, because a fraction usually has a value. If I was to have the fraction 4/5, that would be 0.8 as a double. And so we're going to need a way to access that. And then we're going to have some modifiers or mutators. And the idea behind a modifier or a mutator is that these should change numer or denom in very specific ways. I'm not going to get any data out of this, and so both of these should be the return type void. So I'm going to have void set numer with our int nunum, and a void set denom with an int, off the keys, int new den. So I've got all of these aspects here, which is for our constructor, our accessors, and our modifiers or mutators. And we're not going to do a helper function in this video. We'll probably do a helper function later to allow us to reduce a fraction. In order to reduce a fraction, I need to know the greatest common divisor of the numerator and denominator and divide that out. We're going to do some other accessors later on. And we're also going to do something that's going to allow us to add, subtract, multiply, divide, and print out fractions much easier. But this is our header file. This has all the information that we need in order to create a fraction. But there's a couple of things that I want to do here to make it easier on us when we try and implement this. The first thing is that once I've loaded the header file, I should immediately afterwards include fraction.cpp. In other words, the file that has all the code in it. And what's important to note here is that I'm using quotation marks because I'm not loading a pre-installed library, a C++ library. I'm actually including a file. So I'm going to be receiving the code, and it's just as if that code from that fraction.cpp has been copied and pasted into this document. There's one other thing that I want to do in this fraction.h, and I'll explain what we're doing with it when we get to our next program, is I want to put a preprocessor directive. Now, we've been using preprocessor directives before. The include is an example of one, and they always start with this hash character. What I'm going to do is I'm actually going to define a term, and the term I'm going to define is fraction.h. And so if this term is defined here, then we're in the header file. And if this term is not defined, that means that we haven't accessed the header file before. So this is going to be our header file. So now I actually want to create our fraction.cpp. So I'm going to save this as fraction.cpp. And in here is where we're going to have the code for the fraction class. But I want to take care of that define that we had before, because in our main program, I want to have the freedom to either include fraction.h or include fraction.cpp. And so the whole reason that we did that define is to figure out that, hey, if we haven't loaded the header file yet, we need to make sure that it's loaded first. Now I need to know if we have loaded that file yet, so I'm going to ask the processor using a preprocessor command. I'm going to say if not defined, so if in def, and if fraction.h or fraction_h has not been defined, then I want to include fraction.h as a file. In other words, if it's never seen this term fraction.h, it's going to put the code for fraction.h above the code for our fraction class. And that means that all of these prototypes are going to get loaded before it ever sees the code. And this way I don't have to write the class in such a way that all of the functions that I need are always directly above. Remember that C++ compiles in a top-down way. And so if it reaches a file that, or a function that has not been defined, it causes an error. So I need the prototypes, and I need to ensure that all the prototypes have been defined before I actually start writing code. And then I need to end the if. So what I've done here in fraction.h with this define fraction_h and with this if in def fraction_h and include fraction.h in def is I've created a link between these two files. If I include fraction.cpp first, it's going to say, oh, I have no idea what fraction.h is. Let's load it. It loads all of it and then hits this. But now when it reloads that, it's going to say, oh, fraction.h is already defined. I don't need to reload this. I'm not going to end up in an infinite loop. If I load fraction.h first, it's going to say, hey, I'm defining fraction.h. Here are the prototypes. Now include fraction.cpp. Fraction CPP is going to say, hey, was fraction h defined? Oh yeah, it was already defined. Skip this line and just go to the code. So the way that we've linked these two files, we've made it so that the client or any user could include either fraction.h or fraction.cpp as a file. And again, it's important to note that because these are files, I'm using these quotation marks to indicate the file. I'm not using the open bracket and close bracket that we had that indicated a library. So I want to go ahead and start typing up some code. Now, the first code that we have is the code for the constructor. And our constructor is of type fraction, but I need to make sure that I'm doing the type fraction in the fraction class. So I'm going to see this fraction : fraction. And I've mentioned this before when we first started dealing with cout. I had that using namespace standards, so I didn't have to write std : cout or std : end line, because it sure does save a lot of typing. The problem is I'm not creating a namespace, I'm creating a class. And so for now, I need to make sure that I put that scope indicator in front of every method that I'm going to write. I know it seems tedious, I know it seems excessive, but we need to do this. Now, our constructor for a fraction has two parameters, an int numerator and an int denominator. And what I need to do in the code is I want to say that my numerator is going to get num and my denominator is going to get den. So this is going to store our numerator and denominator in our instance variable, which we define those in fraction.h. So now I need to do my accessors. So my first accessor I had was in the fraction scope, and it was get numerator with no parameter. And all I'm going to do is return numer. And I'm going to do the same thing for get denominator, just return denom. And then we had the other accessor that we wrote, a get value. So I'm going to go ahead and create that. So this is going to be, oops, I forgot the scope thing, fraction : And also remember that these are going to be returning type int. I can't believe I forgot that. What a horrible start we've got here. So I've got a return type of double. This is in the scope of fraction, and this is our get value method. And what I want to do is I want to return our fraction as a double. So I know that I'm going to take the numerator and divide by denominator, but I also know that an int divided by an int is going to give me an int. So I need to take care of this through casting. So I'm going to cast as a double the numerator. And that's going to make sure that we've done the appropriate casting, so we're returning the appropriate type. Now I want to do the modifiers, or mutators. So remember that our modifiers and mutators are all void, but they are in the fraction scope. So it's going to be fraction set numer, which is going to have an int new num. And what I'm going to do is I'm going to say that numer gets new num. And then I need to do my other mutator, so void fraction : set denom int new den, and say denom gets new den. So this is all the code that we have for our fraction class. Notice what we've done is in our fraction header file, we put in prototypes for all the methods that we're going to have, including a prototype for our constructor. And in our code file, we've actually got the code for our constructor, the code for our accessors, and the codes for our mutators. In our fraction.h, we also have our instance variables declared, so I don't have to declare them. And once I've specified I'm in the fraction scope, I don't need to say that numer or denom are in the fraction scope. The fraction scope takes care of it all for me. Now, if I want to, I can compile either of these. And it really doesn't matter which one I compile first. I'm going to do g++ fraction.h. And what did I do wrong? Fraction.h, line 24. Expected declaration before the close brace token. What did I forget? All right, I figured out what the issue is. The first time that I compiled this, let me scroll up to here. The first time I compiled it, it said that it was an error on line 24, but the actual error was in line 42, column 1 of fraction.cpp. And if you notice here, I've got these extra braces. I really don't want those extra braces. So I'm going to delete those and save. And we're going to try recompiling this. So I'm going to do g++ fraction.h, and that compiles with no issue. Now, something you'll notice is I see this file here, this fraction.h.gch, and this is a temporary binary file that really includes all the essence of fraction.h. If I try and open it up, it's going to give me a whole bunch of garbage. And you can see this has got a lot of machine language in here. This is the guts of our fraction that we've created so far. What I want to do to finish up today's video is I want to create a fraction main. And so this is going to be just testing out our fraction class that we just wrote. So I'm going to include IOStream because we're going to be printing out results. And I also want to include fraction.h. In general, you always want to include the header files, but I should have set it up so that we can include either the .h or the .cpp with no issue. Thing you'll notice here is that, again, when I want to load a library, I'm going to use those angle brackets. When I want to load a file, I'm going to use those quotation marks. And now I just want to create a main function to test out the methods that we've written so far. So I want to create a fraction. And remember, we talked about how to create an object. So this is going to be fraction f1 with our parameter list. Our parameters are numerator and denominator, so 2, 3. So that's the fraction 2/3. And I'm going to create another fraction f2, which is going to be the fraction 5/8. So that should work if I'm constructing two fractions. I want to check the accessors that we have. So I'm going to see out, I'm going to do f1.getNumerator and then print out a vinculum. And then print out f1.getDenominator and an end line. And that should print out a fraction, just a numerator/denominator. I also want to test the modifiers, the mutators that we have. So I'm going to say f2.setNumerator, and I want to set the numerator to 6, and I want to do f2.setDenominator to 9, basically incrementing each of those by 1. And then I want to see out f2. The get value method that we wrote. So I'm going to save this and we're going to compile this. So g++ fraction main.cpp -o, and this is going to be fraction main.exe. Have I not saved it yet? No such file or directory. Oh, should be /o, not /0. Ooh. Ugliness. What's wrong here? Oh, the other thing we forgot, using namespace standard. I forget that as well. So let's try that again, once more with feeling, and that works much better. Notice over here we've got fraction main.exe, so if we run this, notice that we have our fraction 2/3. It also created this 5/8 fraction. It printed out 2/3, and we set our numerator to 6, denominator to 9, so this is 6/9. And now when I do f2.getValue, I'm printing out 6/9, which is 0.6 repeating. So I'm printing out 2/3 again. Interesting. So this is how we set up our class in C++. What's important to note is this idea of a header file, which is going to have all of our prototypes in it, as well as our class definition. And our class definition always needs to be enclosed in braces, terminated with a semicolon. I'm using this include fraction.cpp so that these files load each other. And in my fraction.cpp, this is where I actually have the code for each of the methods that I've written, keeping in mind that for each method header, I'm having to indicate the scope that this is a function for our fraction class by doing this fraction colon colon in front of each of these functions. So we're going to continue to work on this over the next few videos. We're going to be adding bits and pieces, trying to make this more robust. I'd like to make this as much of a type as I can so that I can essentially use it just as I do in search-hars. That would really be the idea that we're trying to get here. So once again, this is Mr. Potter. Thank you for watching. Have a great day.